Wyatt is here.
I know
Okay.
some of you guys. Good to see you guys again.
Hey, Wyatt.
Hey, Wyatt. Are
Hey,
we
Wyatt.
live yet? Are we
Oh
live?
no.
Oh, we're live. We've been live for like 10 seconds.
All right.
I'm like, where did the red button of liveness go? Like, I don't understand. Hi, everyone. This is the Data Center News Show. I'm going to pretend to be a podcast host today. I know where my live button is. We are talking data center power, and I feel like a pilot because it's not a data center news show unless Amy has audio issues. So it is one of the things. It's like a running joke. It's the worst thing ever, too. I've got to get a real podcast producing thing eventually. You know, we need to grow up, but get some sponsors of the show, and I can do that. It'd be awesome. Okay. All right, let's start this shit. All these people have been on my show before. They know the ropes. So let them introduce themselves. Marty, go first, sir.
All right. Great to be back. Great to see old friends and make some new friends on your show, Amy. Thanks for having me back on. So Marty Renkus, I'm with Johnson Controls in our infrastructure services division. So we do all types of power and cooling and heat absorption services, all as an OpEx. So we're here to solve problems as an OpEx.
Very cool. Thanks for coming. All right. Hey, Dave.
Hi, everyone. Dave Sterlice. I'm with Vertiv. I'm on our hyperscale sales team, and Vertiv supplies power and thermal solutions for clients large and small.
Thanks for coming. And Wyatt.
Hey, Wyatt Pemberton here with Critical Grid Solutions. We provide solutions for powered issues on or off the grid, in front of or behind the meter. You name it, we support it.
Awesome. And Howie.
Hey, Howard Berry, Avison Young, commercial real estate broker. We have land with power.
No way. Can't believe
Yes.
it.
Power with land, Howie?
Yes.
You have power with land and land with power. Okay. That's awesome. By the way, before Chrissy goes, Howie was my first guest on this show, by the way.
Awesome.
Yeah,
What?
way back in the day.
No.
We are it's now been, it's like a year and a quarter now, like 15 months of this show. And Howie was the first guest of the
I
show.
had no idea.
You don't remember that? Yeah.
No, I didn't know I was first. That's
Yeah.
great.
Because it used to, anyway, I digress.
Anyway, we'll go.
All
Yeah.
right, go,
Party on.
Chrissy.
Chrissy Olson. I'm with MPI Narada, and we are a battery solution and energy storage solution manufacturer.
Very cool. Yes. And this is awesome. This is gonna be a great show because it's anything that anybody in the data center industry cares about, which is power. And so we're gonna talk through. So the couple of the topics that I wanted to get through today, and this comes from real life experience because yours truly is doing development for power and putting deals together. And Raul's here. Raul, you here? Raul, you coming? I don't know. Here's here. He's gonna fight.
Wow.
Raul from Bloom is here. Hey, buddy, welcome.
How are you?
Good. All right, so we're gonna be talking through power. So a couple of the topics that I had, and for all of those who've been on the show, Raul's a newbie. We're just gonna go through stuff, but eventually, does behind the meter become more economical than the grid? And are we going to talk about the latest in battery technologies? Thank you, Chrissy, for being here. And then we're also going to be talking about how data centers are they turning into power companies? Like eventually they might be, right? And some of the other solutions. We got a lot of solution providers on the call. Vertiv was had something in the news. It was one of the news stories I curated for this little event. So anyway, we're going to talk through it. So let's talk through the first topic, which is does behind the meter or our data center. Let's do this one first. Do data centers eventually become power companies? We know that they've been having to do. Trump came out, did his announcement. They all have to build their own power. Is that where we see everything going? Throwing that out to the crowd.
I'll jump in real quick. I was at the DCD Connect show in New York for all of you that were there, and I sat in on the financial bit, which was great, and got to hear Gene Alessandri from CyrusOne. Awesome guy, great company. And I thought one of the best take-home quotes I had from that whole show was Gene Alessandri saying, "Unfortunately, I am now a power and data center company."
Oh,
So I think to answer your question, I think it's a solid yes.
Gene's a great guy. And by the way, I would have loved to have gone to DCD. My flight got canceled. I couldn't find another one. So you must have gone there on Sunday because anybody flew in on Sunday made it, right? Like,
Mhm.
yeah,
Mm.
it was bad. It was bad. Anyway, so I'm all jealous of all you people who got to go to New York. I did not make it. Very cool. Awesome. So Howie, all your developments, are you seeing, are they looking, you're finding land with power, but I'm assuming they're also building their own power solutions too, correct?
I just heard about a deal that got completed in Virginia, 200 megawatts behind the meter with a hyperscaler. I don't know who did it, what the deal. I know who the developer is, and I can't say, but it's interesting to hear that getting done. When it and for the most part, everybody still wants utility. It's a focus on utility. They don't want to become energy providers, and they don't want to be utility companies, data center operators, that is, be utility companies. But when I was at GTC a couple weeks ago, I ran into the GE guys, and one of the engineers is there, and they had a board up that said utility, bridge power solution, and then islanded power solution. And I said, I want to talk to you about the islanded side of things and what you're seeing. And the GE guys said, look, we have a problem. If you're looking for 5 nines, how are we going to, we can't guarantee 5 nines on an islanded power solution. And that's the big concern when it comes to any one of the data center operators, and they rely on the grid. If your power goes out, you can move to another, you can transfer that load off another line or a substation, whatever. And you've got maybe get your power up and going quicker. But if you lose a turbine or a redundant turbine, and you have to go on generators, there's a problem there. So that is an issue. But the neo clouds aren't as sensitive because they're only backing up maybe 25% on some of these major development projects. So they're not completely focused on a 5 9 solution.
Interesting. That's interesting. Did you want to jump in, Dave?
No, I'm in agreement. Yeah, we're seeing the same thing, and it kind of goes back. If you remember the original design tenets of like Tier 4, it was supposed to be you run on your alternate power first, and then the utility is the backup. And it's kind of, in my view, it's coming a little full circle there. But to Howie's point, there's certainly case in point to things, and for us, it goes down to, I mean, there's got to be limits around, how long you can last. We can turbines, of course, are very good and run long time. Gas recips come a tremendous way. So we're not looking at, standalone diesels like we used to. But the sheer magnitude of power, when you're talking in the hundreds of megawatts on up to gigawatt scale, it would be difficult to run that full time. We'll just say so. Right.
Yeah, no, I went to, and I'll let Chrissy and Wyatt jump in. I went to the ERCOT Innovation Summit, which was a couple days ago, and I'm in the room and I'm listening to what they're talking about, and Wyatt and I had a conversation right after. I don't think that even if you go build 2 gigawatts of your own power plant, somehow magically you do. I don't understand how the utility provider doesn't come in and go, that's ours now, because you built a utility inside of our jurisdiction, right? So I don't know how long the behind the meter things last, but I do think they're probably. So I don't know where it fits, and And my big sense of what I got out of that ERCOT Innovation Summit is I don't think they know either. I think it's like we're just all figuring this out together. I think that's kind of my takeaway from that whole deal. It's interesting. I mean, I don't know, but if we look at it, what's truly getting built right now? It's the small sites, right? The small little edge sites, and those are like more battery solutions, right, Christy? Or batteries are more integrated in those smaller sites, right? Like the 10 megawatts. sub 100 megawatt sites are actually what can get through these interconnection queues. And I don't know. You tell me. What are you seeing?
For new projects, we're seeing a lot of modular projects going in, a lot of edge sites going in, unless it's been planned for years, right? Like the stuff going down in Abilene, et cetera. But, that comes with challenges as well. But they're doing some interesting things with, and we are doing some interesting things with skid configurations and containment configurations. And I think like one of the things I keep hearing is if we're going to use different types of, whether it's utility, it's behind the meter, different types of power sources for a large site, the battery backup system and the energy storage solution is going to become more prevalent up front than it is as an afterthought just to back up the UPS, right? We're hearing stuff where people are not even want to power through UPS. So I think we'll see a lot of evolution this year and going into next year on what that looks like.
Interesting. Nobody's that. Wow. I'd love to see a data center with no UPS. That would be tricky.
They're just powering directly to the rack. So
yeah, exactly. Right.
UPS. But again, then that battery storage, thank goodness, is a battery solution is even more important, right? Because everything still has to have a backup to a generator.
Yeah. Depends on your loads as well. So if you're running AI loads, that stresses batteries, and as Chrissy Wells knows, we have to do some things around that to add to the battery so they can hold up better for that purpose. And I think there's still going to be certainly battery energy storage at service entrance or for long duration has a place, but there's still a spot closer to the loads depending on your loads and criticality. And we're seeing, actually, I would counter that with liquid cooling, we have some ride through, but there's certainly probably more UPS being used in CDUs and other places where we never quite saw them in the past few years now. But yeah.
Amy, I'd like to address your kind of initial question is power and data, are they merging, right? Is the megawatt and the compute merging, or are they diverging, or whatever the take on? My take is they are absolutely converging. We're seeing the discussion around compute measured in megawatts, right? We see it from that level, but we're seeing, the lease agreements for rack space to be down to what is your power consumption, and that's kind of becoming the metric that we're measuring, sizing of projects by. And as those projects get more and more and more efficient, or they become much larger loads with liquid cooling, the move to liquid cooled chips, we're going to see more and more and more dense racks that are going to require more and more energy to address the behind the meter or behind the fence or on the grid. I don't see behind meter going anywhere ever anytime soon. That's been in existence in the power world, on the grid, in the industrial world for since the beginning of time, having load behind the generator. It's this behind the fence or islanded. That was the conversation you and I had. I see the islanded as that's a short term. That's a short term deal. That is when the IOUs or the transmission service providers, the TSPs, catch up on studies. They're going to turn and say, hey, based on tariff or based on the language that we have in our state or our jurisdiction, we are supposed to be the utility of record, and I believe they're going to want to claw that back. That is, in their view, they're territorial, and that's their customer, and they're going to eventually get there. So is that maybe an ERCOT, is that legislation that forces all of us islanded guys to go through the grid process? Hey, that's cool. We actually want that. What we don't want is the force to pay very large letters of credit, very large deposits in the $25-50 million range just to get into the queue when we're already built, we're already sitting there. You're forcing me into the system. I prefer not that. So I think there's going to be a lot of policy determinations around what's okay behind the meter and what's okay islanded, and what are the stipulations for that. Policy always takes a while to catch up.
You don't need it. Not if you're Google. You can have whatever you want. Do you guys follow Paul Chernick? Anybody follow him? And super smart guy on LinkedIn. Don't challenge him, by the way, ever. He just talked about behind the meter, right? You know what I'm saying.
Oh, I know what you're saying.
It will be embarrassing. He says, behind the meter, when you're the amount of gas you use on a turbine, 35% of that fuel is used. It actually generates energy. 65% generates heat. So when you're looking at fuel to energy ratio on a behind the meter solution, island power solution, there's a lot of wasted fuel there.
Yeah, let me add something to that, Howie. So we're doing the heat recovery as a service. So we can take a tremendous amount of that wasted heat and using absorption chillers that we've been manufacturing for 60 years. Old tech. This is not new tech.
Yeah, we have to
turn that into chilled water, like almost 3 to 1. So we can take 100 megawatts of turbines recip, turn into about 30 megawatts of chilled water.
Yeah.
So I don't know if y'all know, but Hawaii's built like 70 power plants. So is that true? Where the gas is like 65% of it goes to heat? Is that true?
So I actually saw that post, and was that the one about co-locating at mines? I thought that was a great thing. I haven't pondered.
Yeah, I mean, don't tell him I said that.
Yeah, I haven't pondered it long enough. And I have not built that many. I've been involved in either running or commissioning of something around 70.
Okay.
But I mean, Amy, you've probably seen the statistics from the utility that like 90% is lost by the time it gets to you.
Yeah. I know.
So I mean,
transmission.
Yeah, between transformer losses and everything else.
But I think that looks like low hanging fruit as we go forward for efficiencies. As we go to the fluid cooling, the chip cooling, well, that's going to be the energy transition there is even better. So we look at the heat recovery. I guess Martin, I didn't realize there was heat recovery as a service. We're sitting here talking about data centers becoming power companies, and I think if it weren't for that, I don't think the power as a service would exist. I think it's opened up, a bedroom community of opportunity that didn't exist a few years ago. But yeah, I hadn't pondered the heat portion, but that's going to be low hanging fruit on efficiency. Is if we can bring in an industrial that could sit next door to a data center, to a power plant that's co-located, and use that, that heat recovery. Yeah, we want to be
for power generation.
Yeah, we've seen a couple. I've been involved personally in one with relatively low grade heat in the Netherlands that built an extra greenhouse for the tulips with a regular air cooled data center, and then I think famously the Paris Olympics used heat for the pools and stuff.
Swimming pools, right? Yeah.
And then in the Nordics, where you have district heating, Montreal done some projects there where you get to use district, and that was all before we had full fluid distribution, full liquid cooling, I should say.
Yeah, but like for me, we're in Texas. Like we don't want the heat. Like just saying. So
your refrigerator works better in the heat. You know that. It's more efficient then. So you do want the heat. So
okay, no, I'm sorry.
I do not explain the absorption coolers again.
So what else can we do with the heat? Well, we can use it to make energy, right? But is the conversion ratio from the heat, from the power that is making the heat, can you use the heat to make more power? Does that work? I mean, like, is heat capture and recovery? And I mean, how does that all?
I've only ever dispatched and geothermals, but that's what I think about. I think that companies like Fervo right now may be very, very well positioned. The geothermal guys may be very, very well positioned to use their technology in this situation where they're not actually grabbing the hot water out of a closed loop down into the thermocrust or the permacrust or whatever of the world. Maybe it's literally they're using their technologies at surface level, taking our waste heat and doing what it is. The geothermal technology is gone. It's massively made leaps and bounds in the last 20 years, definitely the last 10. So maybe there's something there. I should have written it down and not shared it. Maybe that was my next business idea.
I want $1 million. I want $1 million.
Yeah.
Way to make it.
Well, and PTC, I spoke to a company out of the UK that is using heat to do vertical farming within the data center. So where they're taking the heat that they're not using and trying to get rid of and using that for actual farming. So they're doing stuff with the cooling, the extra cooled air, and they're doing stuff with the extra heat, which is just ingenious, right? So that was one of the most innovative things that I learned coming out of PTC was utilizing this additional energy for other things, right? And that also ties into community involvement or what the community might need, right? Which we could do a whole separate podcast on.
Which I've done. Yeah. Those knuckleheads.
It's becoming more prevalent, obviously.
It is. Well, with Bernie and AOC trying to do a moratorium, I'm like, seriously, that is not the answer. Moratoriums are not the answer. Seriously.
Especially when their telephone won't work anymore.
I know. Or they can't send an email.
They can't get to their bank and get their money.
It's funny you say that because I saw that article about like energy rates going. They're quoting energy rates went up 250% month over month, and it was like taken out of a quote of one area that happened. And then my doorbell rings, and it's a guy selling solar, and he says to me, "I'm in California," and he says, "Yeah, with all the new data centers being developed in the area, your energy rates are going up." And I'm all, "Dude, you got the wrong guy." And I went to Claude and I said, "Wait a sec, give me 10-year average over tier 1 markets, the growth or the increase of energy rates, and include a CPI line." And the highest energy rate cost was California. And then I said, "Now give me the growth of the data center market over 10 years. And the lowest growth in data center market was California.
Yeah. Y'all aren't building anything.
Fires. They're PG&E recapitalizing on fire costs.
Yeah. It's anybody who's having to upgrade their infrastructure, basically, right? Yeah.
Gosh, I hope somebody comes to my door and wants to data center. So it'll all be recorded on our Ring doorbell.
Oh yeah.
Chrissy, I know you say, don't you want batteries for those solar cells?
Exactly.
That's it. So
He even asked me afterwards, "Should I come back?" I'm like, dude.
Well,
Maybe he wants to sell something else at the data center. Those are the kind of guys you got to pick up that they don't know what no is.
Exactly. You're hired.
That is too funny. I did go to, there was a STEM conference at Texas State University, and I purposely went just to see the vibe because in Hayes County, Cyrus 1 just got voted down for doing a data center development. They did not allow the zoning change for that. And quickly, right after that, King Abbott, our governor, who thinks he's a king, issued an order. You cannot do that to any data center company in the entire state of Texas. I don't care who you are. Like, that's what he did. And they passed that law. Like, he pushed it through, got it, which I'm like, okay, thank you. But I'm like, I'm not sure that's the way we want to go about doing this, but we'll take it, right? It's a win. But it's interesting. And that takes an effect, by the way, in August. So so Texas, they cannot vote you down in the state of Texas. So guess what? We're going to have much more data centers. It's just interesting. I think so when I was there, it was that we're raising the electric rates, right? It was, we're poisoning the water and we're going to suck all the water out. Right. And it's just like, I'm like, I don't understand the phenomenon. Why is this shit that now everybody believes when it's totally wrong? It's not even anywhere remotely right. And you try to combat it with facts or whatever, and they still don't believe you. Like, I give up. And
but isn't water being used in energy production and power plants?
Oh yeah. For sure.
The most water is being used in energy production, right?
Yeah.
So
paper mills.
Yeah.
Do we still make paper? I think we still make paper.
No, but to your point, Amy, like we're seeing the pitchforks come out and the torches come out. And kind of my home county here in Texas, we had a power plant that was proposed to be built and it got shut down. And then in my home county where I'm from in Kansas, they're also fighting tooth and nail. And I think it was Fluid Stack had one that got shut down there a few weeks ago. And you look at it, and they're talking about light pollution, they're talking about noise, they're talking about lack of job creation. So I kind of get that, but from the ag side of the world, where I came from, my background and land, what I've seen in my home county is the have-nots are the ones throwing the fit about the farmers that actually were able to sell or get options on their land, that there are these higher dollar figures. If you're talking about, the going rate for land in your county is $10,000 an acre. I'm just using a flat number, but your neighbor got, and has an option for $100,000 an acre, and they don't want any part of they have enough. So now it's everyone around the perimeter, the moat, so to speak, that first wave of land around the property they got selected. They're the ones going up in arms. And in some of these rural communities, they've been there for 100 years, and they're, everyone is related to everybody. And one person hits the lotto and no one else is happy. So they're not happy until you are as miserable as they are. I hate to say that, but that's kind of what it looks like it's shaping out to be. And that's terrible. That's not progress for humanity. And that's definitely not progress for these communities that can greatly benefit from the taxes that would be created in their community by having an entity like that. Even if it created no jobs whatsoever on any scale, they could do school buses, new roads fixed.
Oh yeah, the tax revenue is insane. It's absolutely.
And then they believe that the only reason those are happening is because someone, city council is corrupted or the county commissioners are corrupted, and I don't think that's
it's a PR case study for sure. Like someone's got to work on that for sure.
But they're sharing the playbook from Michigan to Texas, they're in the Florida and Pennsylvania and New York moratorium and Illinois moratorium. They're sharing the playbook. Like it's
definitely interesting. All right, I'm changing subjects. Let's get back to let's nerd out on power again, because I got a bunch of power nerds on here. Let's talk about this this high voltage DC architecture straight to the racks. Like there's a solid state transformers. I'm saying like phrases I don't even know what the hell they mean. So like, can we talk through what this looks like and what does that mean for a data center? When so Vertiv was in the news, Dave, with their DC 800 volt DC ecosystem. So because of the Vera Rubin stuff, right? That's why it's all happening.
The Vera Rubin stuff, exactly. Yeah. So go back just a few years, and I think still, if you look at like uptime data, fleet average was around 12 to 15 kilowatts a rack, and then obviously these we're talking about. I think production for us is up to 600 or 800 amp racks, which require a lot of heat, heat extraction, I should say. So, and then we're following NVIDIA's roadmap. If you're following that closely, a couple of those dates got pulled in pretty significantly, like almost a year. So we're trying to follow now. Basically what it is a more efficient way. Computers are DC devices. All solid state electronics are DC devices. It's more efficient to distribute at DC. So with that comes some benefits and some new concerns, let's say. So benefits, 800 volts is the same architecture we use for basically for fast chargers on cars. So we let them build out the infrastructure and develop all the products, so we don't have to start from scratch. If you knew me when I had brown hair about 15 years ago, we were trying to start from scratch with 400 volts and doing all this other plus or minus stuff. And I probably have more of it too. But anyways, so I lost a lot by borrowing established infrastructure from the auto industry. That was a really good thing for us, and NVIDIA saw that, I think. And so Vertiv's been able to provide that. Like I said, we followed their lead. But what does it mean? Absolutely, positively, have to have liquid cooling in there. No other way to do it.
Right.
It's just too much power in that box. Absolutely, positively have to have a bus system. You can't do it with individual wires. So we have a back plane in there, just big copper ingots, essentially, that you can tap into. 800 volts is DC in particular, unlike AC, which crosses a zero, DC doesn't. That means it's harder to interrupt, which means it could be potentially more dangerous, which means there could be more incident energy for arc flashes, things like that. So you raise the voltage, you reduce the amps to do that, and there's still some questions to be answered, but it's working out pretty well. And all the hyperscales and many of the neoclouds all already have at least demo versions of this, if not kind of limited production versions of this. And we are shipping, Vertiv is shipping right now 800 volt DC infrastructure.
DC's been around a long time in the telco industry. When I was an electrician, I used to wax rope, lace up cable, DC cable in the telco side. And yeah, it's been around for a long time. Super dangerous, but you know.
Well, the good news with power electronics is you can kind of dial the output on it, so you can reduce the short circuit. But not disagreeing with you, Howie. I've been in those old COs at Telcom, and the exposed bust on the walls, and
yeah, right, yeah, and yeah.
So what does it mean? So like if we're doing DC, but all the other equipment, right? Is it made to take DC? Is it, or what does it do to the design of the data center, and how does it interact with all the other systems like Chrissy's batteries and all this?
We're actually getting ready to launch an 800 volt battery solution.
Oh, interesting.
Within the next couple months.
It's a magic number, apparently. That's awesome. That's cool.
Yeah. So to your question, what the ideal solution when we talked about solid state transformers and things like that. So what it'll be eventually, and this is just starting to be again moved into production, but medium voltage in, let's say 34.5 roughly. So that goes right to 800 volt DC and then distribute at the pod level essentially. So looks like the working bit will be around, depending on who you talk to, 3 to 4 megawatts per block. So a solid state transformer is kind of a piece that needs to be more commercialized. We've seen them before in railroad and buses, and so they're not quite industrial, exactly what we need yet. They're used for some specific applications. Right now, what I think you'll see first is a regular rectifier transformer combination, and then DC distribution into the pod.
Yeah, the lovely sponsor of the show is making a solid state transformer for DC, by the way. So everybody's chasing this. Like it's and it's definitely interesting. I just wondered, so how does will this enable the rack densities that they're trying to, like the 1 megawatt rack?
Absolutely.
Yeah,
Absolutely.
So that's why they're doing it. Okay.
Yeah.
Interesting.
And we actually have designs beyond that right now. So they're designs. They're not in production, but we're doing the logical, the NVIDIA roadmap goes like this. So you just keep following the curve and you end up, wow, that's something. 2 megawatts, you used to get an hour at the big conferences when you had a 2 megawatt data center. Now it's that rack right there, that one. Or in a few years, I think that's going to look like.
Yeah, that would be definitely interesting. So then we're just then we don't need these big, large campuses anymore, right? We just need
It's flipped, exactly right. So it used to be 80% IT space, 20% equipment space. Now it's 20% IT space, 80% equipment space. Completely flipped. So it looks, we got a little, like I call it Lego, but kind of a scale model of stuff that we showed at GTC, and people are amazed. So just those 2 racks are fed by all, the whole table is covered with all this other stuff. And I said, that's pretty much what it looks like. Wow, okay.
So the building size is the same, just different.
Yeah, exactly. Yeah. So a lot more everything else.
Yeah.
And all the work gets done right in that little spot there.
That's crazy. So do we think the electrical infrastructure of the changes over time? Does that gray space then, because somehow will there be technologies that advance so you don't need that much gray space? Or are we just not there yet? I mean, I can't imagine what y'all are going through, because NVIDIA keeps coming up with something. Like, what are they doing? Did they have like minions over there that work like 24/7, never sleep, and they got robots building out their chips, right? Is that what's happening?
Probably.
I don't know. It's like, so how do you build for what? I mean, they give you a roadmap and they totally lie to you and they come out with
So-
something new before it. So what do you? How do we
Yeah,
keep up
like-
with that video?
So like for what we do with the we do overhead solutions for that have all the power and all the cooling in it. Essentially, two things happen. So if you want to, and it's a terrible word and everybody hates it, but if you want to future proof, which we can't, but anyway, if you want to design for the next generation, what you'll do is you'll oversize the manifolds and everything on the cooling side, and then have the ability to have more bus bar and stuff. The other thing that happens is underneath that big overhead distribution piece, you get less and less racks. So it starts out being full, and then if you go to the next generation, then there's a couple gaps in it, and then by the time you're done, there's 3 or 4 little lonely racks down there, but a ton of like support infrastructure around it. So it's pretty interesting.
Well, hey, Amy, you mentioned about the minions at NVIDIA, and Jensen had a really interesting quote I heard of recently where he said, "Hey, for every engineer that I'm paying $500,000, they should be using at least $250,000 in AI tokens."
Yep.
Right.
So it's exponential advancement, not because of minions, because they're leveraging AI to code faster, design faster, and that's real. I mean, that's real.
Yeah.
It's pretty amazing.
We're using it at Facilimax, like no joke. Like if we're trying to build out something or add something to our twin or whatever, like we use AI. Like why wouldn't you? Like it sits there, does its thing, comes back to you, go, no, I don't like that, change that. Like and then it's really it has kind of changed the game for sure.
I find that whole conversation just fascinating as can be. From the power plant side, and the gas molecule converting it to an electron, going to DC, or the AC that we're at today. I find that whole conversation fascinating because, literally, if you build it, they will come. Like if we have 1 megawatt, or if we have 2,000 megawatts, we're going to consume it. And if we're not consuming it all today, it will be consumed tomorrow, or by 2030, or by 2032. Yeah. Even then, there's no real change in the power plant. It's still going to crank out a megawatt, but that load turns over every 6 months, 18 months, 3 years, 5 years. But companies like CyrusOne or Vantage Green, those guys, they're constantly updating. So it's that services industry that services the high voltage guys and the computer guys that are inside those shells. That fascinates me because they're constantly redoing it. I think of it like the grocery store stocker. You always go in the grocery store and it's always stocked. But when does it get stocked, right? Well, it gets stocked at night. Well, those guys, I think that they're constantly, the minions, I hadn't heard to refer to that. They're constantly having to re-up the game as NVIDIA comes out with new chips and new racks and more, the density gets tighter and tighter and tighter. And then I think you get to the point where maybe it is 2032. They come back and they say, okay, our 4 million square foot hyperscale space, we really only need 2 million square feet because we've gotten so dense. We need another power plant. And you come back in because they've just, I don't know that answer, but I find the whole thing fascinating.
I mean, if they had available space, they would stick a rack in it. I would assume you could sell the time.
And who knows if the hyperscale facilities themselves are going to be, legacy in 5 years or 10 years or whatever they're going to be used for. But the edge guys, the small, the neo clouds, the distributed 10 megawatt to 50 megawatt sites, how is that not just the absolute future? I don't know. I'm very fascinated by the technology advances going on in data right now. It's kind of the Wild West versus we're just over here with power plants. Like, we'll supply you the megawatts to do the work you're doing.
So, Chrissy, this one's for you. So what are you seeing? So the latest, you talked a little bit on the battery technology, on the 800 volt, like DC kind of stuff. Are you seeing anything else on the battery technology side that, especially as on the AI workloads, are relying more and more on batteries? I remember Elon came out and basically said, we tried to deploy XAI. We couldn't get it to work until we figured out the battery solution to make it basically work, right? And so, what are you seeing on the kind of the battery energy storage side?
I see a lot. There's a lot of misnomers about lithium technology, right? And there's different chemistries. There's different lithium chemistries. There's lots of different chemistries out there. We're exploring some new chemistries potentially, right? For those jurisdictions that will not allow lithium, just period. But it is one of the safest. And I think it's just an educational opportunity to educate people on the different chemistries, what's safe, what's not. Like everybody just thinks it's an EV battery that's going to blow up in their garage, right? And it's not. It's a data center battery, right? I think footprint is going to be, safety footprint. I think that's going to be a big issue because obviously real estate, they want the real estate for something else in batteries. But I also think that we do a lot of different applications where it's either on a skid or in a container. It can be done outside. I mean, one of the things about our lithium batteries is they actually work better, like your refrigerator, if it's warmer. So it doesn't have to be cooled. So there's some savings that goes along with that too, right? It's easier to heat things than it is to cool it, right? So there's some cost considerations there. The 800 volt, like I said, I can't say a lot about it, but it's coming, right? So, and I think the energy storage, I'm having more and more conversations about energy storage today than I did 6 months ago when I started here. So I think that with all the different power availability, whether it's solar, whether it's nuclear, whether it's the energy storage and how do we reuse this energy we're not using is going to become more prevalent in more projects.
Yeah, I would assume, because especially if they start building all their own power and you're going to have different load depending on the time of day or whatever, maybe the energy storage piece, I don't know. Or are they getting mandates from the utilities like, hey, you got to sell us whatever you're not using? I don't.
Well, I think that there's a couple different instances that's going to impact that community, right? What are we giving back to the community, and is that something that can be reused for something community driven? Again, that's an educational opportunity. Is it stored for spikes, right? Because not everybody's using all at once all the power that they need, right? So I think that we're going to have more and more conversations about that. And what can we use that for? It'll be different at every site depending on where the build site is, right?
Yeah, that's interesting.
Chrissy, have you seen any, I guess, engineering or work about putting the batteries between the generators or the grid and the racks themselves or the shell itself? I don't have any facts on this, but I've heard a lot of discussions around like General Electric, GE, Vernova saying they're not going to warranty turbines that do not have some sort of buffer between the genset and the load. And I guess we're seeing the GPUs, TPUs, CPUs, they fluctuate enough that there's some voltage spikes or whatever. And that in the turbine space, that's liberating blades, right? You get microfractures over time. Death by 1,000 cuts, Chinese water torture. You pick your phrase for that. But over time, right, those blades in the turbine will develop microfractures, and then they will eventually liberate, and you wreck the engine. So I'd heard about that, and I heard that Vernova came out and said, and if you don't have some buffer between them, then we've got a problem. Have you guys started working to address that? And that's kind of a loaded question because I'm from a lot of my installs are all recips today, and we're addressing that, but we're not. That's the bleeding edge of where we're at of this behind the fence world where we're not sure if there's going to be issues on recips because it's a different technology, right? So have you guys been working on that?
Again, I am not an expert in that. That's not my bailiwick. However, I do know we're doing some projects with some gas generation that is all outside. It's containerized, and it is that buffer in between. So again, I'm probably not the right person to ask that super technical but I can get back to you on that super technical question. But we are seeing more things about that where that energy storage and that battery solution or best solution is that buffer in between. And a lot of them are being deployed outside of the data center. Most of them in that are being deployed outside of the data center.
Yeah, we're seeing that. Absolutely. You know, and you're talking about the turbines having issues with that workload, GPU workload, which is funny because the fuel cells actually thrive in that environment where their degradation slows down with the GPU workload. So it's really interesting to see how, you know, a bloom does better than a turbine.
No silver bullets, right? No silver bullets.
I know.
Nope.
What are you gonna do? Well, I mean, like, is I don't know. Someone told me, who told me the other day? I can't remember. We all should buy natural gas futures. But here, stock tips on the show, because we're gonna run out of natural gas. I would never have said that in a million years. I know he's like, no, but like, we're finding that more and more people, it is the fuel of choice, right? And so you're going to see a lot of demand. We're not going to run out. I'm kidding. We're not gonna run out. But it is interesting to see a little bit of constraints on natural gas as people try to build out all of these different things. So buy natural gas futures. That's my stock tip. I didn't say it.
They're giving that stuff away for free in West Texas.
They are. Well, but nobody wants to stick a data center in West Texas. Actually, some people are. But it's not. The problem is the gas isn't where you need it to be, right? If you're going to do edge or you're trying to solve latency issues, with that, West Texas ain't it, right? And so I don't know. How do we? I guess, Wyatt, you're going to have to build a lot more pipelines, Wyatt. We got to get them into the. We got to get them in the metro areas.
Against better judgment, we have found ourselves in the pipeline building space that, you know, it's no longer building laterals. You know, we've got one that's only going to be like 90 feet lateral. It's very, very short to an interstate pipeline. Now we're looking to go very, very big distances. And that's wild to me that we've jumped from where we were just 6 months ago, that we could go to the local pipeline and put in a request for a flange, and they had everything we needed. Today, you know, in a lot of the regions that we're working in, there's no molecules available, or the molecules are available, but they're fully subscribed. And you know, they're on firm transport, and the pipeline doesn't have anything more to offer. So now you have to enter that bilateral third party you know, transaction and procure it from any of the shippers that are on that pipeline. But then that's a whole different bag of problems, as now you're in the gas marketing business,
Right?
and in the gas marketing business now you're trying to procure long-term transport, firm transport to your power plant for your data customer that you have a PPA or with a service level agreement language, you know, in place. That's a hard sell to the hyperscaler or the small data guy, or even to your bank trying to finance the thing, saying we don't have firm supply secured on a 20-year contract today from the pipeline. We're going to go into the monthly or the annual or the Balmo, you know, NextCal, and try to pick up that firm transport off of somebody that already owns it. This is interesting. We're in an interesting time in this business.
White, if you transfer over, is it like you're limited to anything under a mile without going with government approval or something? It takes longer to get just.
Yeah, you've got to get interstate. So there is some things like, was it the FERC 311? I'm not totally not a pipeline.
I'm not familiar. I knew it was something like over a mile, like you're limited to a mile.
There's quite a few, you know, specifications like intrastate versus interstate, and then who the customers, if there's multiple customers or if it's just you and you don't have any off takes, which, you know, in this case, some of these projects are quite small, right? If we're talking 10 megawatts or 100 megawatts or even a couple hundred megawatts, going very far with a pipeline puts you underwater as far as the CapEx goes for that project. But if you're going to go 50 or 75 or 100 miles, you're going to want to pick up a couple projects along the way and a couple customers to help you, you know, socialize the cost for the entire pipeline. As you're looking at, you know, a $500 million pipeline or $750 million pipeline, you can't saddle that all onto one project most of the time. So yeah, we're opening up some new cans of worms that weren't really, I guess, theorized just 6 months ago when we're talking about rack space and efficiency and where Elon is bringing engines and not getting permits for. I mean, and here we are. It's a wild world.
Yeah.
Freaking
So
rules.
I know, freaking rules, man. Air permits, things like that. But not only that is it's just the demand in certain areas. Like, you think you got it, right? You'll source, like we just went through this. You'll source and you're like, oh yeah, I've got enough gas here. We can do 2 gigs. All good. And then all of a sudden, magically they get sucked up. It all gets sucked up and you're having to source and try to figure it out. And what are you going to do? And it's what it is. It's like the same thing. We could talk about equipment. That seems to be a moving goalpost every day. Oh yeah, I can get changes here. Oh yeah, no, I'll get them, 2 years later. Oh no, I can get them 2 years tomorrow. It's like I give up. I give up on the engine, the shuffle.
You're saying, you're using my analogy almost. People are like, oh, which one comes first, the chicken or the egg, the equipment or the off-taker? No, it's 16 chickens and 16 eggs, and they all got to show up at the same time on the same time schedule, and you've got to manage all those. No, it's difficult. I think we need our heads examined for being in this business.
Would you hear the latest request on workloads in ERCOT is 410 gigawatts?
That would be new. It was 260.
It's 410. I'm looking at a chart right now.
Yeah, they didn't announce that on the 31st. But I only stayed for like the first half of the day because I'm like, these nerds, I don't understand.
Yeah, Victor Soares posted something about it.
Yeah, Howie, to that end, I believe that just like what's going on in the solar space where, Trump set a horizon or a sunset, sorry, not horizon, a sunset on solar development and how much they'll be able to, their production tax credits and everything around that, or tax equity, sorry, around that. That's in June, right? So everybody's racing. I think I see the same thing happening in ERCOT with SB6 and now all the little pieces that have to fall in place with SB6 and getting in the queue, because the hope is you're in the queue and then you don't get hit with the letter of credit and the deposit. But the thing is, I think they're going to come back and ask everybody in the queue to pony up, and you're going to have to do that. I've heard the numbers 25 million over a certain volume and then 50 million. I think that's all up for debate. But this isn't about politics on here. But I think
it's always about politics. No, I'm just kidding.
There's so many moving pieces just in ERCOT on that.
A load study at Duke is 30 to 50 million deposit.
Yeah, I'm thinking.
What? In 5 years.
5 years. Yeah. Who's parking 50 million for 5 years?
Nobody.
No one is. Nobody. Yeah, it is interesting. I don't know why these people think they should do data center moratoriums. We're not going to build anything anyway because we can't freaking get the power. I don't know.
We're just trying to get into our fun.
I saw some good stuff yesterday on April the 1st. Mars. Data centers on Mars.
No.
Didn't Cushman put that out or some brokerage?
Yeah. That was pretty funny. That was hilarious. Yeah. All the crazy things, and the people were like, first of all, it's telling when somebody puts out something blatantly fake, and because there's been so much fake news prior to that, they believe it, and I'm just like, y'all, it's April 1st. Did you not know that? Really, this is not real.
I don't know. The truth is stranger than fiction right now. There's some crazy stuff.
So listen, I wanted, before we go, because we got Vernon and Johnson Controls. So we're talking liquid cooling and the loops, but since most power gen is going to need to be liquid cooled also, are there does it all come together like in one system? Does that make sense? Does that provide us any efficiencies? Since the data center companies are building their own power or have power co-located, does the cooling do anything on that side? Throwing that one out there. Do the loops come together? Are they one big loop? They go through the power gen, they go through the rack, they do that? No? Am I crazy, Marty?
Dave, do you want to say anything?
I'm crazy. Yeah, I do these crazy things every once in a while.
It's a good question, Amy. It's a good question.
There is a big facility loop for sure, and so that can be used for other stuff. And then the technical loop is where the IT systems are. So yeah.
So is there any efficiencies gained by combining them or keeping them separate?
Well,
like
the real efficiency is going from forced air to liquid cooling.
oh
So
well, yeah.
that's like a 90% efficiency gain or something like that. I don't know. Marty knows better.
Well, I mean, the thing is that I'd add on to that, and Dave's right. I mean, you can have a multiple loops, but I think, as we mentioned earlier, is we can take that heat off that on-site power, what we've been talking about this whole thing, and bring that in the loop with
So that's
another source of chilled water.
Yeah.
interesting. So that's really that's where you get it from.
One way to add.
Yeah. So to build any sort of efficiencies. All right. So there's a couple of have y'all noticed the little fact that a lot of people, there used to be, like, when I started the show a year ago, it seemed like every day there was an announcement of like a gigawatt here and a gigawatt there. This is going to get built, this one, that, and the other. And I haven't seen a lot of those lately. I guess they've all kind of run into stuff. But there was one, Google announcing 2.7 gigawatts in Detroit, of all places. They're going to build in Detroit for a new data center, and it's going to have 1.6 gigawatts of solar. Did they have any sun in Michigan? Like not in the winter. Like, I don't understand where you're going to get 1.6 gigawatts of solar. That's a lot of freaking solar in Michigan, where it's like, I know, I lived in Indiana. Lake Effect, it's like gray for like 7 months of the year. Like
right where I live.
Yeah.
The Northwest.
I think one interesting topic when at DCD Connect, somebody mentioned this, like everybody's talking about 1 gigawatt, 2 gigawatt, gig, everybody's gigawatting.
Yeah.
But the reality is no data center has built a 1 gigawatt power supply yet. So they still haven't built one. So everybody's talking about it. I'm not saying it's not coming. I'm just saying no one's built one yet. So
Switch in Vegas.
Yeah.
Are they did they actually build one?
Yeah.
Yep. And I am.
No, I mean, it's done and up and
Mine's
running.
being built right now.
Well,
it is.
Built. I'm just saying, no one's built one yet. It's not
No
up
one's
and running.
commissioned one. No one's. It's actually a gigawatt is actually up and running and operating. Right? Not what. That I
No,
do.
Coming.
Somebody
Yeah.
said that. Don't know if it's true, but it sounds true.
Well, Elon kept touting that his was a gigawatt, but it's not. It's like 350 megawatts. Like, basically off of DCD did like a little search and go, based off of this footprint, there's no way to hell he's got a gigawatt there. That's what they said.
We have grid utility, 1.65 gigs.
Oh yeah, the one down in South Texas, right? Yeah. Sorry.
Somewhere.
Did I give it away? Or it's in the state
It's somewhere
of Texas.
in the Texas region.
State of Texas. Yes. Well, you have that, but that doesn't mean somebody can build the plant and use the thing. Like, you might need a couple of people. I don't know. We'll see. Let's get it.
Well,
Let's get it.
Stay tuned, folks.
Stay tuned. But in
He has
this,
power with land.
he does. He has land with power with land. But in this, I wanted to talk about this Google thing, and I'm so glad Chrissy's here, is because they're talking about they have 400 megawatts of 4-hour energy storage. Is that the golden hurrah that you've got 4 hours of storage? Like, I don't, what does that mean? Because, I have to do data center 101. So what does that mean when you have 4 hours of storage?
I think it can mean a lot of different things. It could be the time between the power going out and the generator kicking in, right?
Yeah.
It could mean they have that much access to use for something else. So, I mean, it would need some more context what that means.
But most energy storage is there, because I know nothing about energy storage. They're not really meant to go for 4 hours, right? Or are they? Right? I mean, that's not a long time.
Yeah, I can go for days.
Oh, go for days.
So if you use like pumped hydro, which they do in Europe quite a bit, they can go for days. So you pump it up to the top to a reservoir on top, and then you roll it over a turbine, and you generate your own hydro, and that can go. Yeah, there's been big projects like that. So
Oh, interesting.
yeah, just you got to kind of
You dissect it, right? To,
yeah.
you know, that could be
So
just
there's
a marketing
compressed
thing.
air that can be real long term. There's pumped hydro. There's a bunch of real kind of sounds
Same
real
thing.
exotic, but it's been used for decades in
Okay.
like, industry and stuff. We're just, I know we like to think we're always on the bleeding edge of stuff, but there's some stuff we just, you know, we could do well to pay attention to other industries sometime because they already went through all this pain.
Very true. Very, very true. Well, I think I'm still at Power 102. Wyatt tried to graduate me, but I'm really like Power 102 still.
I'm
All
still
right, okay.
She's fighting it.
energy storage one.
Yeah. Oh, you are.
101.
All right. Well, look at that, y'all. It's been an hour. Can you believe it?
Just like that.
It's been just like that. It's an hour. This is why we have so much fun with the show. All right. This is outro time. If somebody would like to get a hold of you, sir, how could they do
Yeah, look me up. Happy to talk about heat recovery with anybody. Look me up on LinkedIn.
that? Very
Oh,
cool.
thank you, Amy.
And- yeah. And Dave,
Yeah, likewise. See you on LinkedIn.
see you on LinkedIn. Wyatt?
Yeah, absolutely. LinkedIn or just call Amy.
Since I talked to him like 5 times a day. Yes. Very cool. And Howie,
Just ask ChatGPT. It knows how to get a hold of me.
it does. It knows how to get a hold of everybody. Except
I don't know
Claude
how.
keeps forgetting me. Like, I don't know what's up with Claude. Like, I pay, I do all this stuff, I change all the settings, and then every once in a while, it'd be like giving me a stupid answer. I'd be like, do you not know who I am? And it's like, no, who are you? And I'm
You
like,
got to keep educating it.
I know.
You gotta start at your own show or something. Get
I
more popular.
know. Apparently,
Burn those
you
tokens.
know.
You need to burn those tokens, Amy.
Burn.
All
I know.
tokens need burnt.
You should be a bigger token
Yeah.
burner.
I'm a huge token burner. I hit my limits all the time. Like, come on, what are you talking about? They're like, sorry, you're slapped. You have to wait till 10 p.m. Okay, fine. All right, Chrissy, how can someone get a hold of you?
Yeah, all over LinkedIn. Very easy to get a hold of. So
Yeah, it's very cool. Well, thank you guys so much for coming on
Awesome.
the show.
Thanks,
today.
Amy.
This was
Thanks for
fun.
having us, Amy.
See you
Yeah,
next
yeah.
week. Same bad time, same bad channel. See y'all.
See y'all next week.
thank you.
See y'all.
Bye bye.